Problem number 38, find equation of the tangent line to the graph of this function at this x value. That means we need to find the derivative to get the slope. We have e to the some power here that involves x. So to find dy dx, what are we going to have to do here? We're going to have to use chain rule. So dy dx is going to be 5 times e to the 2 cosine x times the derivative of what's up here. What's the derivative of the exponent? The derivative of 2 cosine x is negative 2 sine x. Okay, so we've got y, we've got dy dx. We need to evaluate both y and dy dx at the appropriate value of x here. So y of 3 pi over 2 is 5e to the 2 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. So this is 5e to the 0. E to the 0 is 1, so this is 5. Now dy dx, evaluated at x is equal to 3 pi over 2, is 5e to the 2 times cosine of 3 pi over 2 times negative 2 sine of 3 pi over 2. Now we already established that this expression right here is just 5 times negative 2 over here. Sine of 3 pi over 2 is negative 1. 5 times negative 2 times negative 1 is 10. And so we want to have the point, the point that we're going through, x is 3 pi over 2, y is 5, with slope 10. Okay, and so what is going to be the equation of this line? Y minus y naught is 5 is equal to 10 times x minus 3 pi over 2. And so that is problem number 38. Problem number 39 is just checking to make sure you know derivative rules and stuff like that. I'm going to rewrite all of these as, rewrite the exponents here. This is minus 1/5 times x to the minus first power, minus x times, minus 8 times x to the 1/2 power, plus 14 pi to the 3/2. So the derivative of 2x squared is 4x. Minus 1/5 times the derivative of x to the minus 1 is minus x to the negative second power. The derivative of x to the 1/2 is 1/2 x to the negative 1/2 power. And then this is maybe one of the big reasons why I stuck in this problem on the review sheet. The derivative of 14 pi to the 3/2 is 0. It's not 14 times 3/2 times pi to the 1/2, because this is a constant. There's no x dependence here. So the derivative of this constant is 0. And so this is right here our final answer. If we want to manipulate this just a little bit, 4x plus 1/5 x to the negative second power minus 4x to the minus 1/2 power. So this is problem number 39.